Growth and decay. I am audible? I am audible
Yes,
or not?
ma'am. Yes, ma'am.
Yes, ma'am.
Oh, we discussed for the growth and decay last
Yes,
class.
ma'am.
I think I have solved the example for the
Ma'am,
population problem.
example of bacteria you have done till B part.
Bacteria,
Another 4 parts are remaining. You told you will do today.
which one? Newton's law of cooling.
No, ma'am. After that, a bacteria culture grows with constant growth rate. That one.
Bacteria culture. Oh, so it is present. Okay. So okay. I think I have covered this one up to this. It is over, na?
No, ma'am. Till B part.
Only B part. What was the
Yes.
initial size of the culture? All of you have written the question? All of you have written the question? Initial size of culture. First, you have to find out the relative growth. It is done?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes.
Initial size of culture. That means you have to find out the value of y0. That is also over. Find the expression for the number of bacteria after T hours. Find the expression for the number of bacteria after T hours. That means here we get the value of K, we get the value of Y0, then we write down here it is YT is equal to, I am writing here, YT is equal to we know YT is equal to, sorry, we know YT is equal to Y0 e to the power kt. We got the value of y0, we got the value of k, is not it? So what is write down yt? Tell me. Y is the function of t. What do you write down? What is the value of y0 we got here? Already done, you are saying? Initial size of the
50.
culture. Huh?
50.
What is the value of y0? I am not remember. The y0 is your 50. Okay, very good. So it is your 50. 50 e to the power, then it is your 1.0397. It is here written, so you are saying that 0.4, that is also okay. Then T. Clear to all of you?
Yes,
All
ma'am.
of you clear here? The bit C is over now. All of you clear here? I am asking you.
Yes, ma'am. Yes, ma'am.
So then D. Find the number of cells after 4.5 hours. When t is equal to 4.5, what is the value of yt? We have to find out. So do it. Y of 4.5 is equal to 50 e to the power 1.0397. It is the value of t is our 4.5. So what is the value? Tell me. You have calculator.
Ma'am, 538.
Not audible to me clearly.
Ma'am, 5381.
It is 5, 2,
533.
8, 3. Not audible. Not
I'm writing in
audible.
chat.
Ma'am,
You are writing in the chat.
5338.9.
It is 5382. Is this number? Tell me yes or no.
Yes, ma'am.
You got this number 5382?
Approximately.
Is it?
Yes, ma'am.
Okay.
Yes, ma'am.
You have some network problem, I think. So it is 5382. I've written no, it is nearly equal to 5382. Then the next part of the question is your what is the rate of growth after 4.5 hours? What is the rate of growth after 4.5 hours? Rate of growth means your dy by dt is equal to rate of growth is your dy by dt is equal to ky. We know the value of k is our 1.0397. Okay, and the value of y we know it is your into 50 e to the power 1.0397 t. So dy by dt, we have to find out dy by dt at 4.5 hours. When t is equal to 4.5 hours, that is equal to, what do you write down? 1.0397 into 50, do yourself, that is 1.0397, then it is into 4.5. What is the value?
5595.
Is equal to
5595.
5,
5595.
not audible your voice clearly to me. I don't know. So okay, I'm showing. You say it is your get value or not? Here it is 5382 5596. You got it? You got this value? 5596?
559.
Yes, ma'am.
Yes, 955.
95.
Oh, okay. Yes, little bit error. So 5595 too. Okay. No problem for that. Maybe calculator error. So it is 5595 you get. The last bit, what is saying that when will the population reach 50,000? When will the population reach 50,000? What will do? Here 50,000 is equal to 50 e to the power 1.0397 into t. Clear? Then you have to find out the value of t is equal to, find out your t is equal to
6.64 hours.
6.64 hour. Why your voice is not audible to me? I don't know.
Ma'am, your voice is also cracking sometimes.
My voice is also
Yes, ma'am.
okay. It is 6.64 hours. You got it? Here it is, the
Yes, ma'am.
answer. All of you got it? $6.64. Where am I writing? Yes, it is T is equal to 6.64 hours. So all of you clear how to solve your problems for the bacteria growth or population growth, whatever it may be? All of you are clear here?
Yes, ma'am.
Okay. Now come to the question of Newton's. Here, Newton's law of cooling. What is the theory part of the Newton's law of cooling? If I'll consider here, I'm going to this page. If Tt, depending on the time period T, it is the temperature of the body. Of the temperature of the body. Ts, I'm considering it is the temperature of the surrounding. Temperature of the surrounding. Okay. Then the rate of change of this temperature, that is your dT by, with respect to the time period, dt is proportional to, by Newton's law of cooling, you know, it is the difference between the temperature of the body and the temperature of the surrounding. Okay? All of you know this part? All of you know this part or not? I'm asking you. Why? No one responding.
Yes, ma'am. Yes.
Okay. So now this implies I can write down dt by dt is equal to k into T minus Ts. I can write down this way.
Yes,
Clear?
ma'am.
What is K? K is our proportionality constant. Here, though it is cooling, Newton's law of cooling, the K is negative constant. But we are getting, when we solve our problem, we get the value of K is negative constant. Okay? And we know here, dy by dt is equal to Ky in the population growth. And the only solution of this is our yt is equal to y0 e to the power kt. By using this condition, we find out the value of this Newton's solution of this Newton's law of cooling. So if I'll put yt is equal to T minus Ts, then here what we are getting? Dy by dt is equal to, we get it is dt by dt, where because Ts is our constant temperature of the surrounding, it is our constant value. So we get this value. So here we can choose the value of yt is equal to T minus Ts. So from here we get the value of y0. After getting the value of y0, we can find out the value of k, this k constant. Okay. After getting the value of k, then we solve our problem by using this formula. We convert this to this form and we solve our problems here. So here it is the Newton's law of cooling. Our formula is this one. And And you know this one. Here I am writing yt is equal to t minus ts, or we can write down t is equal to yt plus ts. Then we solve our problem. So now I'm going to solve the one example, first example. Then I'll solve the problems of your book. So here, first example. You want to write down the question?
Yes.
You want to write down the question?
Yes, ma'am.
Write down. A bottle of soda pop at room temperature. Soda pop at room temperature 22 degree centigrade. 22 degrees centigrade is placed in a refrigerator where the temperature is 7 degrees centigrade. Where the temperature is 7 degrees centigrade, that means Ts is equal to 7 degree. After half an hour, the soda pop has cooled to 16 degrees centigrade. After half an hour means T of 30 is equal to 16 degrees centigrade. After half an hour, the soda pop has cooled to 16 degrees centigrade. Then the bit A. What is the temperature of the soda pop? What is the temperature of soda?
Has
Yes.
cooled to 16 degrees centigrade. Then
Bit A. What is the temperature of the soda pop after another half hour? That means you have to find out T of 60 is equal to another half hours, means it is 1 hour in total, is equal to how much? Okay?
can we repeat the bit A?
Yes?
Can you repeat the bit A?
What is the temperature of the soda pop after another half hour? That is your T of 60 is equal to how much you have to find out. Total it is 1 hour from the initial. Here it is given as T of 0 is equal to 22 degree. It is given here. Then bit B. How long does it take? How long does it take for the soda pop to cool to 10 degrees centigrade? To cool to 10 degrees centigrade. The TT value is equal to 10 degree. You have to find out the value of T. Clear to all of you now?
Yes, ma'am.
All of you have written. So what is the data given here? The temperature of the surrounding, the temperature of the refrigerator is our 7 degrees centigrade. It is given. This part is given. See the question. And initial temperature of the soda pop is our 22 degrees centigrade. When T is equal to 0, it is 22 degrees centigrade. It is given.
Yes, ma'am.
Yes, ma'am.
Okay. So what is my and then after half an hour means when T is equal to 30 minutes, it is 16 degrees centigrade, cool to 16 degrees centigrade. Clear?
Yes, ma'am.
Then what we want to find out? The bit A is to find out the another half an hour. After another half an hour means it is totally 60 minutes from the starting point. What is the value? T of 60 is how much we have to find out. Then when T is equal to 10 degrees centigrade, what is the value of that is small t, that time period? Clear? All this data it is given to you. Now by using all this data, now we'll solve our problems here. So can I clear this page? All of you have written. Can I clear?
Yes, ma'am.
Not audible to me.
Yes, ma'am.
Okay. So here it is. What is given? Given it is your T of 0 is equal to T of 0. It is given as 22 degrees centigrade. Ts it is given as 7 degrees centigrade. And T of 30 is it is given as 16 degrees centigrade. Okay. So we know that Yt is equal to, by using the Yt is equal to, it is we are considering T minus Ts. Okay. And the solution, that is Yt is equal to y of 0 e to the power kt. I said to you this what? By using this we solve our problems. So now y of 0 is equal to T of 0 minus Ts. I can write down. Is that clear to all of you? It is clear to all of you?
Yes, ma'am.
Yes, ma'am.
So it is T of 0 minus Ts. That is equal to T of 0, what is given? 22 degree minus 7. So degree is how much here now it is? It is how much?
15.
Yes, it is 15 degree. Clear? So we get the value y of 0 here for this, it is 15 degree. So now we can write down yt is equal to 15 e to the power kt. Clear? So what is given? T of 30 is equal to, when after 30 minutes it is 16 degree, cool to 16 degrees centigrade. So here yt is equal to T minus Ts. Y of 30, my aim is to find out y of 30 is how much? Y of 30 is equal to T of 30 minus Ts, because Ts is constant. So it is equal to 16 degree minus 7 degree is equal to 9 degree. Clear to all of you? It is not. It is 9 degree.
Yes, ma'am. Yes, ma'am.
Okay. So we get the value y of 30 is equal to 9 degree. So now here y of 30 is equal to y0 is 15, then e to the power kt. So it is 9 degree is equal to 15 e to the power kt. Okay. So it is 30. Okay. So now here this implies 9 by 15, that is your 3 by 5.
5.
Yes, I can write down 3 by 5 is equal to e to the power k 30. This implies k is equal to 1 by 30 ln 3 by 5. I can write down. I can write down this value. So tell me what is that value? You have calculator. Tell me the value. It is what you are getting. You are getting positive or negative. You see.
Negative.
Yes. What is that value? Minus
0.0170.
0.01703. I think you are getting. The last one is 3. Isn't it? Take the total value and find out always your value in radiant. So we write down yt is equal to now 15 e to the power minus 0.01703 t. It is our formula. Yt is equal to, after getting the value of k. All of you clear? Up to this, all of you clear?
Yes, ma'am.
Then the next part, what is the temperature of the soda cup after another half an hour? Means T of 60 is how much we have to find. Okay? T of 60 we have to find out. So now here we know it is our yt is equal to T minus Ts. So T is equal to, I can write down, I already told you T is equal to, where I written? Oh, that is in the last. Okay. T is equal to, I can write down yt plus Ts. So T of 60 is equal to y of 60 plus Ts. I can write down. I can write down this way.
Yes, ma'am.
Okay. So here y of 60 is how much here? Y of 60, I'm writing here. Y of 60 is equal to 15 e to the power minus 0.01703 into 60. Find out your value. Y of 60 is this value. So I can write down here it is 15 into e to the power minus 0.01703 into 60 plus Ts, it is given as 70. Clear? All of it clear here?
Yes, ma'am.
Simplify and find out your result. Simplify and find out.
12.408 degrees Celsius.
12.4 nearly equal to, so is here saying 12.40. Okay, so it is 12.4, I can write down on 40. So okay. The temperature of the body after 60 minutes is 12. This is degree. So the last part, what is given? How long does it take for the soda cup to cool 10 degrees centigrade? It is given as I am writing here, Tt is equal to 10 degree centigrade. What is my aim to find out? My aim is to find out the value of T. So we know Tt is equal to, that is equal to your Yt plus Ts. We know it is? We know it is? Clear to all of you? We know it is or not?
Yes, ma'am.
Yes, ma'am.
Okay, this is equal to, I can write down it is 15 e to the power minus that is 0.01703 t plus it is 7. Okay, So it is 7. If it is minus, then we get it is 3. So we get it is 1 by 5. So this implies, I can write down here it is e to the power minus 0.01703 t is equal to 10 minus 7. It is our 3. 3 divided by 15. It is our 1 by 5. Okay. So it is our, what we get this value, if I write down it is your, this implies, if I write down it is 1 by this value and it is coming here, so e to the power minus 0.01703 t is equal to, sorry, don't write down minus, I am taking it is 1 by 5, so is equal to 5. I can write down. I can write down like this. It is 1 by this value, it is
Yes,
negative
ma'am.
sign.
Yes,
I can
ma'am.
write down this. Okay.
Yes, ma'am.
So your ln of, I am writing here, your ln of 5 is equal to, ln 5 is equal to, your value it is 0.01703 t. So t is equal to ln 5 divided by 0.01703. What is the value? Your calculator.
194.50.
It is 94.5. Clear?
Yes, ma'am.
All of you clear here this problem? Newton's law of cooling.
Yes, ma'am.
Though we know the solution of this formula, so by converting it by this way, then we solve our problems. All of you clear here? Now we are going to solve here.
Ma'am,
It is
94.5 minutes.
yes, it is minutes or second. Yes, it is given as minutes or second. Let me check. Pulled after half an hour. So yes, it is minute. Minute.
Okay, ma'am.
Minutes means it is 1 hour.
34 minutes.
Yes.
1 hour 34 minutes. Yes.
Okay. 1 hour 34 minutes. I can write down. So okay. So can I erase or anybody you're writing?
Ma'am, 1 minute.
Okay. Your classwork problem is number 16 and number 15 is given as assignment. We'll discuss both the problems.
Ma'am, again.
Your classwork problem is number 16 and assignment is 15. Can you meet? Completed? It is completed or not?
Yes, ma'am.
Okay. Now come to the question number 16. Write down the question. A freshly brewed cup of coffee at temperature 95 degrees centigrade in a 20 degrees centigrade room.
Ma'am, please repeat again from the beginning.
A freshly brewed cup of coffee has temperature 95 degrees centigrade in a 20 degrees centigrade room. When its temperature is 70 degrees centigrade, when its temperature is 70 degrees centigrade, it is cooling at a rate of 1 degree centigrade per minute. When does this occur? When does this occur? Okay, I'm omitting
ma'am.
this one.
Yes, ma'am.
So we know, as we know that yt is equal to t minus ts. Yt is equal to t minus ts. So here initial temperature, it is given as T of 0, it is given as, how much it is given? Tell me. T of 0, what is it?
95 degree.
Very good, it is 95 degrees centigrade. And the temperature of the surrounding, what is given? Temperature of the surrounding,
20.
okay. So the temperature, initial temperature is 95 degree, temperature of the surrounding this, then I can find out here the value of y0, T of 0 minus Ts, I can write down. I can write down this way. What is the value of y of 0? Tell me.
95.
Eh?
75
Oh,
degree.
sorry. 75.
It is 95 minus 20.
75 degree.
Okay. So what you write down y2 solution, yt as the solution, that is 75 degree. Okay. Then e to the power kt. Then my aim is to find out the value of k. So what is the given question? When t is equal to 70 degree, that is yt, sorry, tt is equal to, sorry, when t is equal to, it is no. When tt is equal to 70 degree, it is given, that time dy by dt is equal to minus 1. It is given that question. What is, when its temperature is 70 degree, it is cooling at a rate of 1 degree centigrade per minute. Not it? So it is equal to your ky. We know our formula dy by dt is equal to ky. We know or not?
Yes, ma'am.
This is equal to your dt by dt or not? I can write down like this. This one. All of you clear? Already I discussed dt by dt is equal to dy by dt
Yes, ma'am.
Yes, ma'am.
is equal to -1 degree. That value is our ky. So here, what is the value of yt? My aim is to find out, because when t is equal to 70 degree, yt is equal to dt minus ts. So that is your tt is 70 degree minus 20 degree is equal to 50. I can write down is 50, yt is equal to, so that I can write down, this implies dy by dt is equal to -1 degree is equal to k into 50. It is clear to all of you? It is clear?
Yes, ma'am.
So the value of k is equal to, the value of k is equal to,
-1 with
it is -1 by 50. All of you clear? How I am getting the value of k?
Yes, ma'am.
So the now yt is equal to what you write down? Yt is equal to,
Y0 into e to the power
that
kt.
is our 75 degree e to the power -1 by 50 t. We write down?
Yt equal to
Okay.
50.
So here yt is equal to 50 where? What is the value of t? My aim is not it? We got the value of yt is equal to 50 here. So what is the value of t? When tt is equal to, when tt is equal to 70, yt is equal to what we are getting? We are getting yt is equal to 50.
Yes,
Is not
ma'am.
it? When yt is equal to 50, what is the value of t? 50 is equal to 75 degree e to the power -1 by 50 t. So find out the value of t. Find out the value of t. It is 50. 1 by 5, no, it is 50. What is the value of t? I can write down this is equal to your 70 by 50 is equal to e to the power 1 by 50 t. So 1 by 50 t is equal to 1 by 50 t 75 by 50. It is minus sign, so that was it is 75, so it is 1 by this here. This is e to the power, yeah, this I've written t correct. So it is t is equal to 50 ln 75 by 50. It's how much?
When T is equal to 20.27.
It is 20.27. All of you got this value?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So
Yes,
all of
ma'am.
you are clear here? All of you are clear here?
Yes, ma'am.
Yes, ma'am.
Okay. Now come to the question number 15. Can I, you are writing or I will clear this page?
Wait a minute.
Over. Over. No one responding.
Yes, ma'am.
I'm going to clear. So come to the question number 15. When a cold drink is taken, write down the question. When a cold drink is taken from a refrigerator,
And what?
when a cold drink is taken from a refrigerator, its temperature is 5 degrees centigrade. Its temperature is 5 degrees centigrade. After 25 minutes, in a 20 degree centigrade room, its temperature has increased to 10 degrees centigrade. Its temperature has increased to 10 degree centigrade. Bit A. What is the temperature? What is the temperature of the drink after 50 minutes? when will its temperature be 15 degrees centigrade? When will its temperature be 15 degrees centigrade? B. Yeah, okay. So what is given data here? Tell me first. Question number 15. It is given to you as assignment. So you have to say me what is the data given. The temperature of the body is how much here it is given. And temperature of the surrounding, how much it is given. Tell me. And what is the condition also given here it is. Tell me.
Ma'am, T0 equals to 5 degrees Celsius
Very
centigrade.
good.
Yes is equal
T0
to
is equal
20 degrees
to
Celsius.
5 degrees Celsius. Then Ts is equal to
20 degrees Celsius.
20 degrees. Okay. Then what is the condition given here? What is the condition? After 25 minutes, in a 20 degree centigrade room, its temperature has increased to 10 degrees centigrade. So what you write down here it is? What you write down? After 25 minutes means T of 25
T25
is how
equals to
much?
15 degree.
It is
10,
10 degree.
10, sorry.
Okay. Okay. What do you want to find out? First, you write down all this condition, then it is very easy to solve your problems. If you write down this way, then it is very easy to solve your problems. Clear to all of you? So, what do you want to find out? Bit A. We want to find out after 50 minutes, we have to find out T of 50. Isn't that it? T of 50 we have to find out. Then B is our, when will its temperature be 15? When T of T is equal to 15 degrees centigrade, then T is equal to how much? We have to find out. Isn't that it? It is clear? First you write down this way, then you solve your problems. So here, first, it is yt is equal to, because we have to solve according to the solution of our differential equation, yt is equal to, that is your tt minus ts. Y of 0 is equal to, that is t of 0 minus ts. T of 0 it is given as 5 and it is given as 20. So we get it is minus 15. All of it clear here? All of it clear here?
Yes. Yes.
So now we get it is our y of 0 is equal to minus 15. So we get yt is equal to, this as a solution, it is minus 15 e to the power kt. But my aim is to find out this value k here. So now it is given as T of that is your 25 is equal to 10 degrees centigrade. So y of 25 is equal to, it is T of 25 minus Ts, that is equal to 10 minus, that is your 20 is equal to minus 10. Clear? So y of 25 is our minus 10 degrees centigrade. So we get here it is now, I can write down this is equal to y of 25, that is equal to your minus 10 degrees centigrade is equal to minus 15 e to the power kt. Check it whether I am correct or not. You check it.
Ma'am, T will be 25 there. E to the power k into 20.
Yes.
Ma'am, last step 0.
I am not audible to me clearly. What you say? What you say? Papa, it is not audible to clear your voice.
Ma'am, there T will be 25. You wrote.
When T is 20, sorry, it is I have written 20. Okay, okay, it is 25. Okay, it is 25. It is equal to 10 degrees centigrade. Okay, now.
Yes, ma'am.
So we get this value is your minus 15 y of 25 minus 15 e to the power kt, is not it? Is equal to what is the value of t? Find out the value of t. Sorry, find out it is your 25. Here you have to write down.
Ma'am, you have to find the
It is
value of
15
k.
e to the power k into 25. So, sorry, this k is equal to. K is equal to how much it is?
Minus 0.0162.
Minus 0.0162. Minus 0.0162. Okay. Then the value of k is you are getting this one. So now I can write down yt is equal to. I can write down yt is equal to minus 15 e to the power minus 0.0162 t. I can write down like this. So what is the question asking? What is the question asking? Bit A. What is the temperature of the drink after 50 minutes? So T of 50 is equal to Y of 50 plus Ts. I can write down this way. I can write down this T is equal to Yt plus Ts. So T of 50 is equal to, I can write down this way.
Yes, ma'am.
It's clear to all of you or not? This one I have written. So T is equal to, I can take this side, only T value. So I can write down this way. Here.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So it is your minus 15 e to the power minus 0.0162 into the value T of 50 plus Ts is our 20. It's how much, tell me?
Ma'am, 13.7 degrees Celsius.
Yes, what is the value?
13.27.
13 point?
327.
13.37.
327.
That means 13.3 I can write down. The value of T, sorry. The value of T, 9. It is your T50 is equal to this. So it is degree. Clear? It is in degree. Celsius. So now, the bit B. When T of T is equal to 15 degree, that is your minus 15 e to the power minus 0.0162 to t plus 20. Clear? So you simplify, here it is, t is equal to how much? Tell me the result. Simplify
Ma'am,
here.
7.81 minutes.
This
67.81 minutes.
67.81. You are saying? What you are saying?
Yes, ma'am, 67.81.
You're not audible to me. It is 67
Ma'am,
point.
I think
Yes.
67.81 minutes.
Okay. So t is equal to 67.81 minutes. Okay. So it is clear. So mind it, when you are solving the finding the value of k, you see here, you write down what you find in the calculator, total value you write down. And you solve, because in your book it is done like that, by writing the total value, not by using the 4 decimal or 5 decimal, writing the total value. Then the book, it is your, by using I got the total value I got here, it is 67.76. I think I got it. Yes, 74 I got it here. But you are getting 81, so no problem here if you do like this. But try to do here what you get the value of k totally, you put it and solve it. So all of you clear here? This Newton's law of cooling, all of you clear or not? Tell me.
Yes, ma'am.
So now come to the half-life. That is your radioactive decay. The radioactive decay means it is decreasing. The radioactive substance decays spontaneously. So if you put that MT as the mass of the radium here, so I'm going to, all of you are written this, can I erase?
Yes, ma'am.
Okay. Radioactive substance decay by spontaneous emitting radiation. Here, if you put the MT as the, like a population, this is MT as the mass of the radium. It is the mass of the radium. Mass of the radium. The rate of change of this mass of this radium is dm by dt is proportional to the.
Question number.
It is your not question number. I am just describing you the radioactive decay. Then I'll proceed first your example. Then I'll do your one question. It is given to you as assignment. Okay.
Okay,
So
ma'am.
radioactive decay. Radioactive is decay. Like cooling, it is also you get the value of k is negative because it is decay, it is decreasing, is proportional to MT. So according to the last year solution, here we get this implies, I can write down it is your dm by dt is equal to km. What is k? K is our negative constant here. Because it is decay, it is decreasing, spontaneously it is decreasing here. So it is k is our negative constant. So what you write down our solution? As you know, it is yt is equal to As we know, it is yt is equal to, that is your y0 e to the power kt. For the solution of that is dy by dt, it is the only solution of dy by dt is equal to ky. So similarly here the solution we get, the only solution mt is equal to m0, that is e to the power kt. So what is m0? Tell me. Like here y0, what is m0 here? What is
Initial
m0?
value.
Yes,
Initial
when
mark.
t is equal to 0, the initial value what is present, that is our we call as the m0. So here, by using this formula in radioactive, we solve, but here in decay terms of half-life, physicists express the rate of decay is in terms of half-life period. So here, first we solve the example, then it is easy to solve your problems. So write down the question of that example.
मैम फास्ट लैंड कौन लिखा है जी?
What are Papa? Empty.
मैम जो ऊपर, हाँ हाँ,
This one, radioactive decay.
ओके मैम.
Shobhar? So now, write down the question. That is your example 2. The half-life of radium. The half-life of radium, the name of radium 226 is 1590 years. The value of T is 1590 years. Okay? The bit A. Bit A. A sample of radium, a sample of radium 226 has mass of 100 milligram. Mass of 100 milligram. Okay? Find a formula for sample. Find a formula for the mass of the sample that remains after T years. That remains after T years. Okay? Bit B, after T years. You have to find out your formula in terms of T. Bit B. Find the mass after 1000 years. M of this you have to find out. Correct to nearest milligrams. Correct to the nearest milligrams. Then C. When will the mass be
मैम
reduced? Yes.
कैन यू रिपीट पार्ट बी?
Find the mass after 1000 years. Correct to the nearest milligrams. Milligram. C. When will the mass be reduced to? When will the mass will reduce to 30 milligram? What is the value of T when MT is equal to 30 milligram? Okay. So initially What is the value it is given to you? The half-life of radium is 1590 and the initial value it is here, it is 100 milligram. M0 is equal to, the data is saying that M0 is equal to 100 milligram. So MT is equal to 100 e to the power kT. All of it clear? All of it clear here? MT is equal to e to the power kT, 100 into e to the power kT. All
Ma'am,
of it clear?
M0 100.
It is given. A sample of
Where?
radium 226 has mass of 100 milligram.
Oh, sorry.
Initially it has 100 milligram. Initially means that T is equal to 0, that is our M0. Clear?
Clear, ma'am.
Okay. Then what is given when T is equal to 1590, it is half-life. It is your half-life. That is your Y of T is equal to, that is your Y of, that is 1590 is equal to half-life means 100 by 2. That is your 50. Initially it is 100. At this year it is half-life, so it is 50. Okay. So now this is equal to, this 50 is equal to Y of this value. What do you write down? We write down it is 100 according to this our formula, e to the power k, then T is our 1590. I can write down like this, and all of you clear here this point? All of you clear this point? When T is equal to 1590, it is half like this. So it is here initially the life is 100. M0, when T is equal to 0, the mass it is 100. So at this here it is 100 by 2. So it is 50. So that 50 is equal to 100 into YT is equal to 100 into the power KT. T is our this value. So we get this. It is clear?
Yes, ma'am.
So this implies it is our e to the power 1590 k is equal to 1 by 2. 1 by 2. Okay. So k is equal to what you get? It is 1 by 2. I can write down it is minus ln 2 divided by 1590. Minus ln 2, it is ln 1 minus ln 2. Ln of this value is your ln 1 minus ln 2. Ln 1 is 0. So minus ln 2, 1590. Clear? So find out in your calculator what is the value of k. You have calculator, what is the value of k? Find out.
minus 4.35941 into 10 to the power 9.
The value of k is your
Minus 4.3594 into 10 to the power minus 4.
minus 4 point.
Yes, ma'am.
Okay. Divided by this, you are getting this value minus 4.3. What do you say? I think it is wrong. You are finding your value in degree or radiant? I am asking you.
I'm radian, ma'am.
Okay, it is minus 4 point.
Yes, ma'am.
4 point.
Ma'am, minus 4.359 into 10 to the power minus 4.
10 to the power minus 3.
4.
Acha, okay. This one. This one.
Yes, ma'am.
Okay. So now after getting this value, then the question, what is the question asking? Find out m of, so now you can write down yt is equal to, you can write down yt is equal to, that is 100, e to the power, the value it is minus 4.359 into 10 to the power minus 4, then it is your value t. I can write down this way. Then what you want to find out? Sorry, it is I have written yt. Sorry, it is you have to write down m. Here it is m. So what you want to find out? M of 1000. Bit B. So we write down it is bit A. Bit A is over. Clear? All of it clear here? Bit A is over. Write down in terms of T. I think it is given after T years. It is clear to all of you or not? I am asking you. What you say the value of K I have written here, and I have written your MT is equal to 100 e to the power minus KT, that is K is this value. Clear?
Yes, ma'am.
Your voice is not audible to me. All of it clear here? In terms of T, I have written MT. Okay? It is okay or not?
Yes, ma'am.
So now M of 1000 is equal to 100 e to the power minus 4.359 into 10 to the power minus 4, then into 1000. Tell me the value.
64.65.
So
665.
it is 65 milligram. Nearest,
Definitely.
though you are saying 64.6, it is 65 milligram. The question is asking about the nearest milligram.
Okay, ma'am.
Clear? Clear here? This value?
Yes, ma'am.
Then the next question, when will the mass be reduced to 30 milligram? At what time? So it is 30 milligram. I'm going to write down here the bit C. So 30 milligram. I'm writing directly. 30 milligram is at what time? 100 e to the power minus 4.359, sorry, 359 into 10 to the power minus 4, then T. So T is equal to how much? Hello. T is equal to how much?
2520.09 years.
25.
2520.
No, it is coming to 762 years. Check it. You say this value it is correct, but here it is. Check it.
Yes, ma'am. 2761.7.
2761.
2762.
Yes,
Yes, ma'am.
it is 2762. That is your years. All of you clear? All of you clear this problem?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now solve the problems. What is given to you as assignment? Question number 9. Solve the problem, question number 9. Can I omit? Can I omit this page? No one saying
Yes,
clear
ma'am.
this page or
Yes,
not?
ma'am.
Okay. The half-life of cesium, the half-life of cesium-137 is 30 years. (137) is 30 years. The half-life of cesium-137 is 30 years. Suppose we have a 100 milligram sample. Suppose we have a 100 milligram sample. Initially it is 100 milligram sample. So it is your find the mass that remains after T years. That remains after T years. B. How much of the sample remain? How much of the sample remain after 1000 years?
Now once again.
How much?
Part A.
Part A. Find the mass that remain after T years. Okay. B. How much of the sample remains after 100 years? After 100 years. Okay. Then C. After how long? After how long will only 1 milligram remain? Only 1 milligram remain. Okay. All of you have written?
Ma'am,
Yes,
can you
ma'am.
repeat A again?
Again.
Just the bit A.
Again, I am repeating total question. You write down. The half-life of cesium-137 is 30 years. Suppose we have a 100 milligram sample. Bit A. Find the mass that remains after T years. B. How much of the sample remain after 100 years? Sample remain after 100 years. Then C. After how long will only 1 milligram remain? What is the data given here? What is the data given here? Half-life is our 30 years. Isn't it? half-life is our 30 years. The T value for the half-life. So what is the sample data is M0? M0 is how
100
much?
grams. 100 grams.
100. So
100
MT is equal to, we write down, it is our 100 e to the power kT. Clear to all of you? Clear this line to all of you? Half-life means that is 100 by 2 in 30 years. That is equal to T. So I can write down 100. This implies 100 by 2 is equal to 100 e to the power k into 30. I can write down this line. All of you clear here?
Yes, sir.
All of you clear here? All of you clear here?
Yes, ma'am.
Yes,
Find out
ma'am.
the value of k. You find out the value of k.
Minus 0.02310.
Okay, minus 0.02310. All of you got it? The value
Yes,
of k is equal to this implies it is your 50. It is your 2. Okay? Ln 1 by 2 by 30. K is equal to ln 1 by 2 divided by 30. That I can write down minus ln 2 by 30. That is, you say, what you say, minus 0. What you say your value?
02310.
02310. Okay. We get the value, the value of K. You see, it is half-life period, radioactive decay, so we are getting the value of K is negative. In Newton's law of cooling, also we are getting the value of K, it is negative. So now here, what we write down our MT? MT is equal to, we write down, it is your
M0.
100 e to the power minus 0.02310 t. Clear? Write down, it is, the question is given, write down in terms of t. Yes, it is bit A is over. Bit A is over. Clear to all of you? Bit A is over. It is clear to all of you? Okay. So what is the bit B? Bit B. How much of the sample remain after 100 years? M of 100 is equal to 100 e to the power minus 0.02310 into 100. Is how much, tell me? After 100 years.
9.921 milligram.
9.92 milligram.
Okay,
Almost 10 milligram.
it is 9.92 milligram. You say that is 9.92 milligram. Okay. Then the last bit. After how long will only 1 milligram remain? MT is equal to 1 milligram. See, it is 1 milligram remain. It's equal to 100 e to the power minus 0.0231 into t. This implies your t is equal to how much? Tell me.
199.31 volt.
Hmm?
199.31 volt.
19. No, I think you are wrong. I have done
Ma'am,
it is
298.39.
1 milligram is equal to, you are writing e to the power minus 0.32310 into t. So what we are getting here, it is t is equal to this divided by this one here. It is, we get it is, I'm writing here, it is,
199.
no, it is your 0.231 sorry, 0.0231 t, if I write down, is equal to 100. Is not it? Is equal to 100. So it is the value is equal to 1 by 100. I've done wrong here. It is, you see, this by this is equal to this. No, I've written
Ma'am,
correct.
299. 299.
Ma'am, 199.
199, ma'am.
1. The value of t is 199.
Yes, ma'am.
Yes, ma'am.
No,
Ma'am, I
I
am
got
getting
it
299.
0.01. I got it 0.01. Okay, I'm wrong somewhere. Let me check here. Okay, it is e to the power minus 0.023 minus, okay, I'm writing here, it is e to the power minus 0.0231 t is equal to 0.01. Okay. Okay, okay. Yes, yes. Yes, I'm wrong here. It is 199. Only 199 or 199 point some?
Ma'am, 199.31.
199.35.
The value of t is equal to. The value of t is equal to how much you get?
199.31. Yes.
199 point something or 199 only?
0.3.
199.31.
0.3, that means it is years. So you have to write down point. It is not written here, the write down the correct up to some decimal. You have to write down it is 199.3 years. Okay? So you are correct. So it is, so all of you clear this problem? All of you clear?
Yes, ma'am.
Okay. So now what is remain? Let us see your PDF. See your PDF now. I'm going to show you that PDF. It is your, this question is over. Now, '16 it is also over. Assignment question. 3, 5, 9, 15. 9, 15 it is over. Do it at 3, 5. So now, do yourself that question number 3. The answer is with me because it is odd number, so the answer is inside the book. I'll check. First you do it. A bacteria culture, write down the question. All of you write down the question. A bacteria culture initially remain 100 cells. A bacteria culture initially remain 100 cells and grows at a rate proportional to its size. Proportional to its size. After an hour, the population has increased to 420. Find an expression for the number of bacteria after T hours. Bit A is find an expression for the number of bacteria after T hours. Then bit B, find the number of bacteria after 3 hours. Bit C, find the rate of growth after 3 hours. Bit D, when will the population reach 10,000? When will the population reach 10,000? Do it yourself. Now you do it. Already I have done one problem by using all the data. Do it yourself.
Ma'am, please say question again. From beginning.
From the beginning.
Yes, ma'am.
A bacteria culture initially contained 100 cells and grows at a rate proportional to its size. After an hour, the population has increased to 420. Find an expression for the number of bacteria after T hours. Bit A, this one. And bit B, find the number of bacteria after 3 hours. Bit C is find the rate of growth after 3 hours. Bit D is when will the population reach 10,000. Do it. Done? You are doing or not? I am asking you.
कौन सामान स्कूल जाओ
Yes.
स्कूल वाला में स्कूल
Ibun Mahanti, you are present here.
Yes, ma'am.
Tell me. In terms of
Ma-
t,
Yt equals to 100 into e to the power 1.435 t.
1.4.
Ma'am, after 1 hour, y1 equals to 420.
Express bit A is your expression for the number of bacteria after t hours.
Yeah, ma'am, my k is
After
equals to
1 hour, the population has increased to
420.
420.
Yes, ma'am. Then k equal to 1.435.
1.435. You got all of you got it?
Yes, ma'am.
Then bit B after 3 hours.
7,408.
7,000.
408.88.
Asutosh, you are saying?
Yes, ma'am.
Yes, tell
Same,
me.
ma'am.
Asutosh.
7408.7.
4081. Nearly equal to.
0.7.
Okay. 17. So 7, you say 7408. But in your book, it is written as 7409. A little bit error. Okay.
Yes, ma'am. Yes,
Then,
ma'am. It given 7.408.88.
oh, so that means it is for 9.
Yes, ma'am.
Then the split C on Harish Chandra. Harish,
Calculating.
yes, you are getting, do it. Bit C, the rate of growth after 3 hours. Bit C is that one. The rate of
Ma'am,
growth after 3 hours.
10,594.
I am never asked to Sibun and Ashutosh. I asked to Harish.
Ma'am, I'm getting 10,628.9.
10,628 you are getting. Ashutosh, what you got?
Ma'am, 10631. Point.
Sibun, you also?
Ma'am,
You have
yes, but little bit error in my first. I
some
first tell
error
that
you may
10,000.
have. In your
Yeah,
book,
yeah.
its answer is 10,632. Some of you got that 631, and some of you got that it is 6,228. So some error may be in your
Ma'am, in
calculator.
decimal I got
Okay, then beat easier, na? When will the population reach 10,000? After how many hours the population reach 10,000?
4.44 hours.
No, it is wrong. Check it.
3.209 hours.
3.279 hours. That means it is 3.3, but in your book it is 3.2.
3.209 hours.
or 20. Okay, it is 3.2. All of you got it?
3.21.
Yes, sir. What you are saying? 3 point?
No, ma'am, I'm asking what was the answer of bit C?
You are asking the answer of bit C. It is 10,632 in your book. Some of you got it, it is 10,631. Some of you got 628. So it is calculator error, I thought. What you got? Yes. You are asking? Yes.
Ma'am, 10,632.076.
Yes, it is 10,000. You are getting 12,000 to 10,000.
Ma'am, 10,000.
Okay. So you are correct.
Okay, ma'am.
So all of you clear here? Now the question number 5. So I think you have book. You have book or not? You have book. Question number 5. Write down that question number 5 first. The table gives estimates of the world population in millions from 1,750 to 2020. Bit A. Use the exponential model and the population figure for the 1,750 and 1,800 to predict the world population by using these two. Predict the world population in 1,900 and 1,950. By using this, you predict the world population in 1,900 and 1,950. Compare with the actual figure. Compare with the actual figure. What is given in your table? Compare with that. What you find. Then bit B. Use the exponential model and the population figures for 1,850 and 1,900 to predict the world population in 1,950 and only 1,950 and compare the actual population. C. Use the exponential model and the population figure for 1,900 and 1,950. Predict the world population. Sorry, it is 2,000. It is 2,000. World population in 2000. Compare with the actual population and try to explain the discrepancy. It is year, it is population, year, population. It is starting from 1,750, 1,800, 1,850. Sorry, it is 00, 50. Then here it is 1,900, 1,950, 1,200. The population here it is given 790. Here it is given 980. Here it is given 1,260. Here it is given 1,650. Here it is given 2,560. Here it is given 6,080. Okay. We know our
And what-
solution of I. Yes.
Now what you have written in front of 1850 population 1,260.
I am doing all this bit A. You look at your book and do yourself B and C. Yt, we know it is Yt is equal to y of 0 e to the power kt. If you consider 1,750 year st, 750 year st equal to 0, then what about the 1,800 t is equal to t is equal to 1,750 if I am considering initial, starting t is equal to 0. So 1,800 t is equal to is 50. 50 years. Okay. So when t is equal to 0, what is the value of y0? It is given 790. Y of 0.
Yes.
It is 790 given. I'm considering this is the initial. So yt we can write down is equal to 790 e to the power kt. When t is equal to 50, y of 50 is equal to, it is your 790 e to the power k into 50 is equal to, what is given? 980. So what is the value of k? Find out here. K is equal to 1 by 50 ln 980 divided by 790. Is not it? Find out your value k. After getting the value of k, then what will write down? What is the value of k? You got it here. Tell me.
0.00431.
0.00431. Okay, we get it here. So we write down our yt is equal to that is the value 790. Sorry, it is 790 e to the power k is 0.00431t. Okay, so in 1900 the value of t in 1900 t is equal to 150,
150.
and in 1950 the value of t is equal to
250.
200.
200. So find out y of 150 is equal to 790 e to the power 0.00431 into that is your 50. Is 150. What is the value? And compare here in this value with this value. Then you find out y of 200, that is your 790 e to the power 0.00431 into 200. Find out that value and compare here with this value, actual value. Like this, you solve B and C, and this article is over. Next class we'll discuss that chapter 4. Same process, B and C, process are same. Okay. What you got? 150 at t is equal to 150. Can anybody?
1508.0579.
It is your 150. What you get?
1508.0579.
1500.
Yes, ma'am.
1500.
8.
1508.
Yes, ma'am.
It is
1508.
yes. Then 0.50. It is a point over chalo. So what is the, you compare here, it is less value. Like this, what you get here, that is less or greater, you have to write down. Compare. Only the question is asking about to compare. Okay. So now your time is over. Your teacher is waiting for you. I'm going to stop sharing. Do it yourself.